Okay, so we are going to look at graphing a polynomial function. And I have listed out the 4 steps to do that. So the first thing is we want to find our x-intercepts. Then we want to look at our behavior around those x-intercepts. So looking at multiplicity. So in this case, all of our degrees of our factors are odd. So that means when it hits that x-intercept, it's just going to go right through that x-intercept, and it's not going to bounce off of that. And so if it had been f of x equals, let's say, x squared times x plus 1 or something like that, let's just look at x squared. Your 0 is x equals 0. So when you go to graph that at 0, what's going to happen is it's going to hit that 0 and then bounce back up. So it's not going to go through the 0 like it will with x equals -1 coming from right here. So x equals -1, it's just going to go through it. So that's what we're talking about by bouncing off of that x-intercept. So we'll save that for a different problem. We're going to look at the function I've already written down. But that's the idea behind step number 2. So step number 3, we want our y-intercepts. And step number 4, we want end behavior. So write all 4 of these things down and also add them to your graph as you're going through, because it'll make a world of difference if you are also going off of your graph and kind of thinking through these 4 steps. So let's look at step number 1, which is x-intercepts. So where y equals 0, and that happens when x equals 0. So I'm getting that from your factor of x. When x equals -1, getting that from the factor of x plus 1. And when x equals +1, getting that from the factor of x minus 1. So let's put those zeros on our graph right away. So I'm just going to do a rough sketch of it. It's not going to be beautiful, but it'll work. So let's put some markings down so we know what we're looking at here. So we have x equals 0, we have x equals -1, and we have x equals 1. All right, so there is step number 1. Now step number 2 says behavior around those x-intercepts. All of these have an odd degree for your factors. So it's x to the 1, it's x plus 1 to the first, it's x minus 1 to the first. So that means that at your zeros, it's going to go through all of them. So maybe you want to just put a little dash on all 3, saying, I know that I'm not going to bounce off of those. I'm going to go right through them. And now it may be going in the other directions. We need to keep that in mind. But as long as we have some idea here, and maybe you just want to write a letter underneath them saying C for cross and B for bounce. So C on all 3 of those. Whatever will help you. So that's step 2. Step 3 is y-intercept. Y-intercept happens when your x is equal to 0. So y-intercept, what does y equal when x equals 0? And so I can see right away that I am going to be multiplying by 0. So I know that my y-intercept happens at y equals 0. So I can go right there and add it to my graph. I've already got that point down, but I'm just going to add it again, just so it's clear to myself, or clear to me, that I have the point 0, 0, and I have searched for that y-intercept. Step 4 is end behavior. So let me do that in a different color. Let's use red for this. So step 4 is end behavior. Now we need to figure out what our leading term is going to be. So if you were to FOIL this all out, please don't FOIL this all out. You don't need to. All you need to do is look for the largest degree. And I see that the largest degree is going to happen when I have x times x times x. And I have no numbers in front of those, so I don't have a coefficient. And we just have x cubed. And if we were to continue FOILing, we would have a bunch of other terms. But I'm not going to bother FOILing the rest of it because I don't need to. All I need is that leading term. So it is positive, and it's an odd degree. So positive and odd degree. Let's write that down. Positive and odd. Now, I know from my end behavior problems that this is going to give the shape that looks like this. So it's going to go up when x goes to infinity, and it's going to go down when x goes to negative infinity. So when I add this information to my graph, what I'm going to do is in the top right corner, I'm going to put an up arrow. And in the bottom left corner, I'm going to put a down arrow. I'm not going to instantly try to connect it because I just want to get all of my information down on my graph. And I'm not going to stretch this arrow super far because that might confuse myself when I go and try to connect the x-intercepts. So I'm just going to give myself a little hint saying that it's going to be going up in the right-hand corner when x goes to infinity, and negative when x goes to negative infinity. So now I'm going to go ahead and start connecting. I would go from one of the sides of the graph. So either go from right to left or from left to right. Don't start in the middle. It's going to be too confusing to start in the middle. So I know I'm going to go from right to left. And I know that I need to be up here with this arrow. So let me fix that. I am going to be up here. And I'm coming down towards this 0. And I know that I have to go through that x-intercept, and I'm not going to bounce off of it. And I see that I need to also go through this x-intercept right there. So I'm going to start going up, go through that x-intercept. And then I see that I also have this third x-intercept that I need to go through. So I'm going to go back up and go down through that third x-intercept. And then this is wonderful because I'm in the right direction to finish out the end behavior going down. So here is our graph. And let's see if I can't get the eraser, but this is what our graph looks like. And we could kind of clean this up a little bit if we wanted to. So this is just a rough sketch over here. If I wanted to clean it up, it would look something more like this, where this is 1, and we have our 0, and we have -1. So that's how you graph a polynomial.